Dear students, today we will see hierarchical agglomeration clustering, commonly known as HAC, which is a very important topic in BDA. So, HAC starts with one cluster. HAC assumes that each point is in its own cluster. It iteratively merges the points. It iteratively merge all the points until it results in one single cluster. What do we mean by that is, let's say we have certain points like this. So HAC assumes that each point is in its own cluster. So each point is in its own cluster. HAC starts merging the clusters together based on certain criteria like shortest distance, farthest points, or average distance. So it first merges two points together to form one single cluster, and then it merges other points until it results in a one single cluster. HAC uses bottom-up approach for merging. HAC uses dendrographs to represent the clusters. HAC is represented using three techniques: single linkage, complete linkage, average linkage. Single linkage makes two clusters by joining 2 points which are nearest to each other. Complete linkage makes clusters by joining points which are farthest from each other, and average cluster makes clusters of points based on average distance. HAC finally draws dendrogram of the clusters. Dendrogram is a tree-like structure. Let's say if we join cluster 2 and 3, let's say if we join cluster 2 and 3 together, then a dendrograph of this kind would be made. Then we join point 5 and 6 together to form one cluster. Then later on we join these two clusters to form one big cluster, and so on. The dendrogram is created. We will use RStudio to implement HAC using dendrograms. Now let's try to understand this further using taking a question. The question says, find the clusters using single linkage technique, use Euclidean distance and draw the dendrogram. So this is the question given, and this is the data provided in the question. So I have simply plotted all these points on X and Y axis using 2D graph. So the first thing what we have to do is we have to find distance between all the points. So we use the formula of Euclidean distance to find distance between 2 points. Let's say we find distance between point number P1 and point P2. Point P1 is represented as 0.40, 0.53, and P2 by 0.22 and 0.38. The formula for Euclidean distance says to find distance between 2 points who are represented by xy and a comma b, the formula is x minus a whole square plus y minus b whole square. So using this formula, we will find distance between points P1 and P2. Putting the values into the formula, 0.40 minus 0.22 whole square plus 0.53 minus 0.38 whole square. If we solve this, we will get 0.22. So this is the distance between point P1 and P2. Using this formula, we have to find the distance between all the points. That means we have to find distance between P1 and P2, P1 and P3, P1 and P4, P1 and P5, P1 and P6, and P2 and P3, P2 and P4, and so on. So using the same Euclidean formula, if we apply the formula on all the points, this is what we get. So this is the matrix which we get after applying the formula of Euclidean distance between all the points.